Hello, everybody. Hi, I hope we all are audible and visible to you. Yep. Good evening, people. I hope you had a really good day at yuHacks Day 1 yesterday and all the different kinds of workshops that we had for you. And today is our second day. So, hope you are having it nice so far. And our first workshop today would be for Best Practices in Data Science by Dr. Shevan Vafa, who works at TD Bank. And he's also an economics professor at York University. I would like to like him to introduce himself so we can take the workshop ahead.
Thank
Yeah,
you.
over to you.
Yeah, maybe I'll start sharing my screen because I do have an introduction slide, so maybe that would be a good starting point. Just give me one quick second. So I guess while I'm waiting for the slides to load, uh, just a big thank you for the opportunity. I really appreciate the time, and I hope that you will find this session useful. I'll try and go through what I've tried to put together is a bit more general because different people take different things away from these sorts of talks. So I try and make it broad enough that it would be useful to the majority of the folks on the call. If there's any questions, if there's an area you want to dive deeper on and ask any questions, I'll try and leave as much time as possible towards the end so that we can get those questions. Um, Maybe I'll just share my screen because this is taking a bit long, Kanika.
Yeah, no problem. That's okay.
I tried to upload the deck to the platform, but it's just taking so long. So let me know when you can see the screen.
Yeah, I think it's visible to me. I want somebody from the people to confirm it for us. Yeah, I think it's pretty visible.
It's
Yeah.
visible. Okay, perfect. Excellent. So about me, I did my PhD at York a while back in economics. So I did my PhD in uh, impact of like it was mostly international monetary theory with the focus on impact of quality of financial institution capital flows. A lot of econometrics work, and I did some computer science in my undergrad as well at U of D. It was computer science and economics. It set me up really nicely to move into the field that I am in because it's a lot of storytelling, there's coding, there's lots of math and stats. Put all of that together, you get to, you're pretty set up for the world of data science or analytics. At the time when I was doing my PhD, I worked on census data. That was an experience I actively sought out to make sure that I can compete in the job market and I'm ready to go into the job market. Did a lot of statistical modeling there. I also consulted in the Ministry of Finance on time series modeling. Took all of these opportunities basically to pick up as many skill sets and both on the theoretical side, but also on the applied side as possible. Joined the Ministry of Transportation. That's where I got into spatial econometrics, which is a really, really interesting way of looking at data in general. Then I joined the Ontario Medical Association, used OHIP data, did a lot of attribution work, network analysis, panel data, all sorts of modeling there before I joined TD initially as data science lead, doing a lot of NLP automation, propensity models, and things like that. And eventually I became a people manager, and now I manage a fairly large team of 16 data scientists, and we take about 4 to 5 co-op students every term as well. I do have 3 little kids at home, so in case if you're wondering uh, where my time goes, it's either work or 3 kids. I'm a huge soccer fan, and if you are one too, I would love to connect. I love classical music. I play the piano. That's another hobby that I have, and I read a lot every day. As much time as I have, it goes towards machine learning reading. I love history. I also do a lot of work and reading and training in strategy and leadership as well. So that's about me and my background. So can I give you a sense of where I come from and where a lot of the stuff that I show you is based on my own personal experiences. This does not represent the view of TD or anything like that. It's just things that I've picked up along the way, experiences I've gained, and None of it is obviously hard and set in stone. Um, there may be things that people disagree with, and but that's what worked for me and for what I've done and where I've been, and particularly the industry of financial institutions as well. Right? But let's start high level. So we'll start very high level, and then I'll slowly dive a little bit deeper into some of the different components here. Right. So firstly, what is analytics? It's hard to define, but essentially it's using data to solve business problems, making decisions, right? And you take data. So as a data scientist or as an analytics professional, you could be a business insights analyst, you could be a business intelligence and reporting analyst, or you could be a data scientist or machine learning researcher, right? At the end of the day, regardless of what function or capacity you're working within, your aim, your goal is to take the data, use the skill sets that you have, which is your toolbox of modeling, data manipulation, programming, all of that, right? Use that toolbox, take that data, translate it into a solution for a business problem, right? Whether it's executing, whether it's measuring things, whether it's helping define or pivot strategy, right? That's what we call analytics in general. You hear artificial intelligence a lot, and these two things are related, right? When you think about, I just want to differentiate just a little bit because for me, artificial intelligence is something that it's sort of like an end state, right? It's like a collection of systems that work together, and it builds off of models like machine learning models or deep learning models, right? Deep learning models, obviously, as some of you might know, is a subset of machine learning models, right? And so typically when you enter the world of data science, the first thing that you get exposed to are machine learning models, right? Which are essentially algorithms or statistical models that help you uh, capture complexity in the data and achieve a certain task, right? Um, you zoom in a little bit, you get to deep learning models, which are neural networks with certain types of structures and architectures aimed at different tasks, whether it's text generation, like Google BERT, whether it's image recognition, whether it's creating data out of voice, and so on and so forth, right? And of course, when you build enough of these, whether it's deep learning models or machine learning models, you can put it all together. And eventually, you can have an artificial system, which technically means that it's an entity that can understand and it can reason and it can decide and learn for itself and decide, right? Um, that journey, though, when you start, most companies, when they start off with business intelligence, which is tell me what I need to know to keep the lights on for my business today. How many customers do I have? What are my sales numbers are like? How many customers am I losing? And questions like that, right? Which is like very ad hoc. Tell me what's happening today, or tell me historically what happened and how did I get here, right? The next evolution on that spectrum is business insights. So now that you know where you are and you have a good grasp of where your business sits and you have all the metrics defined, the next question is like, how am I going to go? How will I be able to change some of my targets and some of the business strategy and product construct and things like that, right? And so that's when business insights come into play. Typically, folks who work in that field are very good with SQL, lots of business acumen, so they can solve a business problem really well, and they do know a little bit of machine learning as well, right? The next phase, the next evolution from there is data scientists or people who do develop models and focus on machine learning or deep learning, right? And these are individuals who are very, very well versed in statistics and math, as well as programming. They're a lot more specialized. So while you do require them to have good communication skills, project management skills, and all of that, it's not as big of a requirement as it would be for a business insights analyst. And of course, certain industries have moved on slightly to self-serve, so no code, low code environments, and eventually, you will see places where there are systems that are fairly autonomous, right? Like Shopify is a good example where they have a fairly autonomous system that looks for different metrics and finds opportunities for optimization for its clients, and it just prompts them to say, hey, I see this particular product selling really well, would you like to do a campaign on this one, right? And it's fairly autonomous end to end, right? And sort of, so that would be sort of the end target state. Along the way, though, at every step of the way, regardless of where you are, there's always a measurements component, which you may know of as A/B testing. You might know or heard of as experimental design, or test and learn. All of those refer to the same thing, more or less. But it's like, can I quantify or can I optimize or refine the solution that I have by collecting additional data from my customers, right? And that's a huge component, it's a core component in that journey end to end, because it kind of orients you, it helps you get the most value out of the investments you've made, whether it's your models or some other kind of work that you've done, right? So where, what does artificial intelligence do for you as a business, or machine learning, or data science? First, in my opinion, it helps you deal with uncertainty, right? How do you best disrupt the current value creation chain? Well, go back to the data, use insights, create models, and that will give you additional tools and insights that you would not have had otherwise, right? Second, I think it adds an additional layer of discipline to think through obstacles and potential pitfalls. For example, you want to achieve a certain thing, right? You want to add or boost your acquisitions, whether it's product acquisition or account acquisition or customer acquisition. You create the model, you go through all the different hurdles, and then what ends up happening is like, oh, I'm actually getting the opposite result of what I expected to get. I think that forces you to go back in, gives you a new way of thinking, new discipline of thinking. Is like, okay, what happened, right? And what did I get wrong? What assumption did I miss? Or what did I miss in this whole end-to-end process? So it exposes you to a sort of like a blind side. If you were blindsided, it exposes you to an area where you didn't know about that you need to pay focus and attention to. For example, did I really understand my customer needs? I thought they would need this product, and the model suggested that they wouldn't. We did everything right. But what happened? Well, maybe it's only a segment of that customer who needs that product, right? If you're trying to sell investment products to individuals, some would be interested, some wouldn't. Maybe they want to buy a house soon, right? So they wouldn't want to tie down their money to your product. So it helps you really get a better hold of what your customers need and what you need to do differently. And lastly, when you have data, I mean, if you've set it up nicely, then it helps you move to a more agile fashion where it's like, let's try things, let's test them out, and let's measure, and then redefine or refine our plans and what we want to do. It's no longer a static thing where it's like, okay, beginning of the year, I'm going to do this for this year. No, every quarter, every month, you're looking at it, and the data might tell you something different. You need to change things around, right? And that's why this field is exploding. That's why this field is so exciting to be a part of, because it has this inner potential to transform a business, a company, and do things that you would not have been able to do before, right? So I've talked about why it's important. When you bring it one level down, it helps you with the top line, so you can increase revenue. It helps you with bottom line, so you can reduce costs. And here's some examples of each. I won't spend too much time on it, but it also helps you manage risk. It also helps you improve your own colleague experience, the experience of your own employees within the business, right? Who are your coworkers, essentially, right? And so it has a ton of potential to impact a wide variety of sort of areas within the business. At the end of the day, though, where analytics in general is most impactful is where the business is razor sharp focused on what the customer needs. You might have all heard of Amazon's leadership principles. First principle, be customer obsessed. That customer obsession, there's a reason why that's the number one principle at Amazon. Because if you can understand your customer, if you can remove barriers for your customers so they can use your products more, what are you doing at that point? You're increasing your revenue. With increased revenue, with increased number of customers, over time, you reduce your average cost as well, right? And so you become more and more profitable. But it all starts with the customer. It all starts with understanding the customer and making sure that you're giving them what they need and you're giving value to the customer. Then they'll give you value back. And that's where analytics is super helpful. Okay, so I've given you a sort of like a very high level explanation of what analytics is, AI, machine learning, where those sit within analytics. I've given you a sense of what that evolution could look like towards AI, for example, and why is all of this stuff so important? Why is it so integral these days to any business, right? Regardless of what you do, data is probably the biggest asset. and how you use it really differentiates you and gives you a competitive advantage compared to your competitors in the industry. The next question is, okay, so how do I actually do this, right? What is that method? What is the methodology? Or what is that framework that I need to go through to be able to extract the most value out of this data, right? The approach we typically take, and I'll go into a slightly more depth in a few slides, but just very high level. Just want to make sure that you can clearly see the pillars, essentially, right? Typically, you start by defining the business problem, right? Defining the problem means that you need to understand the business. What does this business do? Facebook has lots of different products, right? Whether it's Instagram or whatever. So, what is the essence of Instagram as a product, or what is the essence of Facebook as a product, right? Within the Facebook platform, there's a ton of other product owners and product spaces, right? So, you need to really understand, for example, when you have an ad button, what is the function of that ad button? What is the target? What's the objective? What are the challenges? What are the trends? Understand that business or that product in and out. And then you understand the data as well, right? Because without the data understanding, there's not a whole lot you can do, right? So that's what I mean by define. Once you really understand the context, then you can define the business problem really well. Then you move on to the next phase of, okay, let's do exploration and figure out if you have the right data and explore that data as much as we can to see if it tells you, anything useful at that point, right? Are there correlations that you're finding? Are there particular patterns? Are there customer segments? Anything that might be informing a potential solution for that business problem. Then comes the analysis part, which is where you saw the earlier graphs that I showed you. So it could be business insights, it could be reporting, it could be a machine learning model, deep learning model, any of those. That's where you sit down. It's like, okay, for this particular problem, it makes sense to do a machine learning model. And you might question and say, okay, but how do you actually know when is the right time to do machine learning versus something else, right? Typically, there is no clear-cut answer. I think it comes down to a lot to the complexity of the problem. If you find that you're cutting down your target variable by a whole bunch of different explanatory variables, at some point it gets too complicated for you to tell a cohesive story, right? And that's when you start to sit back and say, okay, does this actually make sense? Do I just keep going and cutting this by all these different exploratory variables, or do I just feed it into the model and then let the model capture that complexity and then help me explain some of those relationships and helps me focus? It's like, hey, you gave me 200 different features that helps explain traffic to my website. That's great. But as a machine learning model, it can also tell you which of those features are the most important. Something that as a human being is a lot more difficult to do when you have 200 features, right? Then the next phase is, now that you have some results, you want to be able to communicate, whether it's storytelling, whether it's visualization. Sometimes it's the tool itself that you make it available to your users. And you focus a lot on transparency, on making sure that the solution you've built is usable by your business partners. And then lastly moves to the operationalization phase, which is maybe you have a model, you push it into production. Maybe you have a web app that's fueled by the model that you built. So many different ways where you can operationalize your solution essentially. But high level, again, that's the methodology. It goes end to end from definition, problem definition, which is arguably the most important step, all the way to the other steps. So let's get into some of the different types of analytics you could do, right? As I mentioned before, you can have data. You start with data, essentially, right? Then you can do descriptive works, which is you try and answer questions of like, what happened? I see there's a dip, or sorry, there's an increase in my customer attrition. And all of a sudden, I'm losing a lot of customers relative to last month, relative to last year, or just the trend is downward sloping. And so that's your description of what happened in the past, which is like the hindsight. I'm looking back and, okay, this is what I see. The next question is, okay, that's good. Now I know that there's a trend that I need to pay attention to. Now I want to know why. What's happening? Why did it happen? Right? That's where you get into insights. That's where you are creating lots of graphs, maybe PowerPoint decks, or maybe dashboards and things like that, to try and tell a story as to why you see this particular pattern, right? And then sometimes that leads to be building a model. So if you're losing customers, sometimes it would make sense to build a model to identify who those customers are proactively, right? So you can reach out to them and say, hey, I have a feeling you're going to leave in 2 months. You won't say that actually to the customer, but the customer will get an offer for a certain product. They will get an offer, or some sort of a refund or something, right? Or maybe it's just a conversation to have. It's like, hey, what's missing? Is there anything that we can do for you differently, right? Are we meeting your needs or not, right? Um, so it could be that, but all of that would be informed by that predictive power of the model, which will tell you, will give you a probability or propensities for all your different customers or different accounts, and will say this customer is going to stay, this customer is going to leave, and here's why they're going to leave. That's what the model will tell you. And you take that insights, and then you try and create a program, or you try and create something more proactive where you moves to the next phase of what can we do about this, right? You have to make some sort of a decision to be able to rectify that situation, right? So you now move into the action phase. You take action, right? You get some feedback. So that's the measurement piece, right? You get, like, you do your A/B testing and whatnot, and that informs you of what else you need to do, or what do we need to do differently. Now you go back to the data, and this cycle keeps going and going and going over and over again. Maybe not on a weekly basis, depending on what the nature of the product is. If you are in the advertising space online, you have enough traffic to be able to do things a lot faster. Whereas if you are running a campaign in a physical store, you need a lot more time to really understand what's going on, because you don't have as much traffic. So the cycle, the speed really depends on the nature of the product. But the cycle will have to be there always, for the solution to be effective, the solution to be transformative. So what are some of the different types of analytics or predictive work that you can do? You might have heard of supervised learning before. Typically, machine learning models are broken down into supervised and unsupervised. And within unsupervised, you can have self-supervised and a few different categories. But let's keep it simple. Let's say there's two types, which is supervised and unsupervised. With supervised learning, essentially, you know what your target variables are. There's a label. You have a group of customers. You know some of your customers are, let's say, um, credit. They'll be more likely to get a credit card, as an example. I'll use a banking example, versus a group of customers who will not. So you can actually group those customers, right? And you look at them in the past. It's like, we gave this customer an offer, they took the credit card, but this other person didn't. So you can label each customer one by one with, let's say, a 0, 1, 1, 0, 1, 1. So you know exactly, um, your what your target variable actually looks like, right? In these sorts of problems, you use a different type of algorithm. You would use a classification algorithm, or you would be a multi-classification or multi-label algorithm. Sometimes it's a regression problem, because you're trying to forecast maybe how much they would spend in the future, as an example, right? But at the end of the day, you know exactly what you're trying to forecast or classify. You have the numbers, you have the data, it's all labeled, it's all very clear. That's what is known as supervised learning. Alternatively, that's typically what you see in all the marketing campaigns, right? Should I show this ad to Shevan, or should I show this ad to somebody else? Or maybe Shevan needs this other ad, right? So that's like a recommendation system, as an example, right? Where you know exactly what you want to show to whom. And that's sort of a supervised exercise most of the time. The alternative is that your data is not labeled, right? And it's like an open box. I don't really know what the data, or you don't really know who Shevan is per se, like what his preference would be, right? You have to infer that based on some of the other characteristics. So that's where you get into unsupervised learning. One good example is, you might have, let me use an online example again. Maybe on Netflix, you have lots of different viewers, lots of different customers, right? And you're trying to get a better sense of what are your, customers who come to you regularly, so that you can just track their usage and see how often they watch something, versus the ones who are occasional binge watchers or something like that. It's like, hey, I'll watch something once a month or once every other month or something like that, right? And you really want to understand what type of movies would attract them, what type of series do you need to target things differently, right? And so within each of those segments, you don't really know much about them, other than, okay, they don't do this, they don't watch frequently, anything frequently, right? So then you bring in some of the other attributes. Maybe it's their age, where they're located, the platforms they have, and all of that. You put it into a algorithm, and the algorithm will create different clusters for you. It's like, so of the ones who are not actively using Netflix, there seems to be three types of people there, right? X, Y, and Z, whatever they are. And then for each of those, you might decide to do a different type of run a different type of a program to activate them, right? Help them, or nudge them to get on the platform more often, by maybe offering them something that's more relevant to them, or reminding them that, hey, did you know you can also watch stuff on your phone, or something like that, right? But it generally helps you build clusters and make sense, or create personas out of your customer base, or it could be your spending data, or whatever that it might be. But you don't really have a clear target in mind. It's very exploratory in nature. So typically speaking, as a data scientist, machine learning researcher, these are the type of projects you will be working on, whether it's supervised or unsupervised. A lot of an NLP like natural language understanding, natural language processing, are projects, are very they're essentially unsupervised exercises, right? You're trying to make sense of the text. Maybe you have customer data, customer feedback for Expedia, as an example, and you're trying to make sense of that data and drive any sort of insights that you can, right? First, you need to process that data, then you run it through these algorithms, and then you create different clusters or different for topics, right? What are some of the key topics people are talking about when it comes to this particular type of accommodation, or this particular hotel, or a type, airline, or whatever it might be, right? Those would be generally those would fall generally under the unsupervised learning. So, we've kind of understand what analytics is, why it's important, what is that end-to-end process looks like, what are the broad categories of type of models that you can do. And the last thing I wanted to cover is something that I generally share with the team, especially people who are new to the team, which is, what are those key best practices as the practitioner, as the person who does the machine learning, or does the analytics. What are some of the, what's the framework, what are the guidelines you got to follow to make sure that you get the most value of the time that you're spending and the investment you're making in a solution, right? You want to make sure that solution is viable, usable, makes sense, and it's reproducible, replicable, explainable, all of that stuff, right? So typically it starts by, as I said before as well, verify the problem, identify the source of the problem. Someone comes to you and says, hey, I think our attrition numbers are going down, and they're panicking. Sorry, the attrition numbers are going up and they're panicking. Your first job as the data person is to say, okay, what do you mean by attrition? How do you measure attrition? What goes into that metric? Let's decompose it and really understand how it's calculated. Is it month over month? Is it year over year? Is it voluntary? Is it not voluntary? Did something happen? Did we have a regulatory thing that happened that resulted in us having to close customer accounts? Their Amazon accounts. Was there like a fraud thing? We need to understand what they mean by attrition, and then verify and say, yeah, this makes sense. This could be a problem or not. A lot of times you want to go back. If you have cubes, if you have reports, if you have dashboards, go and check. As even if you are the deep learning expert and you're asked to solve a problem, you want to make sure you ask those questions to really fully understand that, yep, there is a problem here to be solved, right? So again, as I said before, I said it again now, I'm going to repeat it a third time. Always, always, always refine the problem, verify the problem, understand the business. I cannot overemphasize how important that is. And you will see once you are in a workplace how you will get engaged many, many, many times to work on a problem that is not a problem. And it's not on purpose. It's just because, someone who owns a particular product, it's very easy for them to panic or misrepresent or misinterpret the data. Sorry, not misrepresent. And so your job is to ground them as the data person, as the expert who as a person who's an expert in data. Your job is to ground people. Your job is to make sure that they are actually focusing on the right problem. Second step is, okay, is this even worthy of my time? Right? You might be a machine learning expert. Does this problem require machine learning or not? Right? So there's two components to that. Is there enough complexity here for me to work on? And is there enough value in this? Because building a model is very, very expensive. It's a very expensive investment to make, right? When you think about the development time, the testing time, the deployment and the engineering that's required, it is a huge investment for most organizations. Do you want to make that investment? Is it worthy of, the benefit that it brings? Does it outweigh the costs, right? And is this problem complex enough to require a model, right? If not, there's other teams who can deal with this. There are insights teams, or there's other data scientists who can take this on. Once you've passed those first two questions, the third thing is, let's clear the objective. Let's make sure we have a very, very clear objective. What does it mean for all of us to say, yep, we succeeded? What does success look like? You will always ask that question, right? What does success look like for this particular problem? What should I give you, right? So that collectively, when we are done in 3 months, 6 months, 1 year, we look back and say, yep, we succeeded. We set the target or the objective as this, and we pretty much got there, or we exceeded it, right? This is not something you do on your own. You are not typically the person who sets that objective. It has to be a collaborative exercise where it's like maybe yourself, there may be data folks, there may be business people, there may be regulatory folks who are involved, privacy. It's typically a team effort. So it's like, realistically, given the constraints that we have in the organization, what can we achieve here? Then you move on and say, okay, now that we know what we want to do, we know this is the right problem to solve, and I'm the right person to do it. Next question is, how long is it going to take me to do it? Can I do it in a week? Do I need 3 months? Right? And what are my timelines? What am I working towards? Right? Sometimes you need to support a campaign, a marketing campaign. When it comes to that, you have very little room for negotiations. Like, you want this by a certain time, so you have to get it done by then, right? Sometimes it's an AI solution or a machine learning, like an NLP solution that's ingested into a software. Software release cycles are typically 3 times a year, right? And it's, from the beginning of the year exactly what that date is. So you got to work backwards from that date. Say, okay, if this is my timeline, then realistically, this is what I can achieve. But you need to know what those timelines are, right? Really, really important. And then you engage the right partners. Is there anyone else downstream who needs to be involved in my decision making of the model I'm building, the way I'm doing it, how long it takes for me to do it, and all of that, right? It's your business partners, maybe it's your software developers, whoever it might be, that somewhere downstream will be consuming your model or your output. They need to be involved day one, not day 100, not at the end. Day one, right off the bat. They need to know that this is coming, right? Next, then you create, typically what we do at least is we create a work back schedule, right? From that date, all the partners, we sit down together. It's like, here are all the things that need to happen for this to go live. This is my responsibility. This is marketing. This is data. This is regulatory, etc. Right? But it needs to be all in one confined view. It creates transparency. It creates, brings more trust to the process, and it helps everybody focus on what they need to achieve by when. Now, as the data scientist, you've officially moved on to the execution phase. Right? All of this was until now, it was all sort of like planning, essentially, which some of it is your responsibility, and some of it, as I said, is more of a team effort, right? Or a group effort. So now, as the data scientist, you move into the execution phase. First, foremost, data. 60% of your time, I have it on the next slide. I should probably put it here, but more than half of your time will go towards understanding the data, exploring the data, and knowing what you have access to, internal data, external data, all of that, right? It will be a lot of time and a lot of back and forth, understanding the lay of the land when it comes to the data piece. Along the way, now that you've started execution, what I typically recommend to my own data scientists is like have daily touch points. Even if it's a 2 minute meeting, or it's like a 2 minute email or a chat on Teams. It's like, hey, by the way, I did X, Y, Z, or here's some challenges I face. Here are some accomplishments I've had. Anything that you can share, keep that going. Whether it's you're sitting in a pod, even better. That gets done through Jira automatically every day. You have stand-ups and whatnot. If it's not in a pod setting or an agile setting, make sure you create that environment, at least from a communication aspect. When it comes to time to build a model now, spend a lot of time on feature exploration. What features should I include in the model? In what folder? How do you engineer your features? That's a very important process, because um, while we have a very deep and wide range of data, different types of models that we can use for different tasks, you will find the majority of the time the model is secondary to the quality of the data. The impact of the model is secondary to the quality of the data and the features in particular, right? It's more about what features, what signals you're feeding into the model as opposed to what model you use, right? So a lot of time on feature exploration, a lot of time on feature engineering, or you actually engineering the feature in the right way to be fed into the model. And then the model, you will see that it will pick up the right signals, right? Most of the time, a base model, which is like an XGBoost maybe, or light GBM, that will do the job for you. You can always tune the hyperparameters, give it a little bit of a boost. But if you have the right features fed into the model, then you're probably 90% of the way there for most use cases, right? And then the other 10%, it's like, okay, let's make sure we have the right model. Let's make sure we tune the hyperparameters and so on, right? But the choice of the model becomes important for a completely different reason, which is sometimes you need to be able to explain what the model is doing, right? So that's the model exploration. And sometimes the model needs to tell you what features are important and give you additional insights. So that's the feature explainability piece of it, right? So your regulatory partner will come and say, hey, I can see you have some sort of a risk model that will tell you, what's the risk of doing X, Y, and Z. Why did you choose this model and not some other model? And you need to be able to explain why. So that's the modeling piece. And then the next question is, well, you're telling me that you're going to lose X amount of money if you do this, but what explains that? So then you have to dive deeper into the models. The model needs to be explainable. Tell you like this particular feature or input to the model predicts this and has this impact on the outcome or on the target variable, right? And um, a lot of times that explainability is required, and there are some other times that it's not. So you can just throw in a deep learning model into a problem. You don't have to necessarily explain it, as long as it does a really good job of explaining the or predicting or forecasting, then it's good enough. One other thing I haven't listed here, or actually I have. So monitoring of the model is super important too. Uh, well, you build a model and it goes into production. There are lots of things that can happen, right? The environment can change, the economic environment can change. As we saw with COVID, your distribution of your features can change. So you need to monitor that on an ongoing basis. At some point, maybe the ranking of the features change. Customer preferences can change over time, right? And so something that explained customer behavior 2 years ago may no longer be as important anymore. It could be interest rates in a banking setting. For Amazon, it could be I don't know, the choice of platform as an example, right? Like whether it's on the app or online, etc. So you need to keep an eye on the feature rankings, on the feature distributions, and how do you do all of that? First, you start from the very end, which is your model predictions, and you make sure you have guardrails in place for the predictions of your model, right? If your model has a precision or recall as its metric, or just accuracy, for example, you say, you know what, I'm going to tolerate a little bit of a drop in accuracy, right? It's not perfectly scientific, but there is some logic behind it. It gets more complicated. It's like, you typically look at the business impact, not necessarily just the model performance deterioration, but it's like, if my AUC drops by, let's say, 5 percentage points, or by point zero 0.05, what's the monetary impact of that drop, right? And if it drops by another 5, what's the monetary impact of that, right? So you set guardrails, and you monitor the performance of the model over time to make sure that it's not damaging the business. Super important, right? There's a huge risk that if your model deteriorates significantly, you end up losing a lot of money. You might have all heard of Zillow's attempt in the US to forecast underappreciated real estate markets. And I think they put in $300 million, something like that, into that business model, and they lost all of that. And I don't know the full details, nobody knows. But when it comes to forecasting, it's super difficult to do, especially in real estate. But you have to make sure that you have guardrails in place. And you should be monitoring this either on a monthly basis or even more frequently, depending on the type of model and what it does. Other best practice: Git code repo. Make sure everything goes into GitHub or Bitbucket, and you understand, you're comfortable, you're an expert when it comes to structuring your code really well, adding comments, pushing your code up to your repo, to the right branch, and all of that. This is one area where a lot of people come out of school and they're not very well versed in. So if you have the chance, and I suspect because most of your computer science students, you'll be experts in this anyway by the time you graduate. But extremely important to really understand the best practices in coding, and commenting and so on. It's essentially basically your software practice, right? Software development practices. And lastly, documentation, something that everybody hates and everybody needs at the same time. The more documentation you have, obviously, is not better. It's not about the volume, but it's about the quality of the documentation, right? It's what you document and how you document it that matters, more than just like documenting everything. Not everything is relevant, right? And so making sure that you have good documentation within the code, commenting within the code, making sure that you have a good description of the problem, of the different sort of different files that you create. Maybe you pickle your models, and you have to make sure there's proper descriptions, like when this model was pickled and what it does, and so on and so forth. But all of that to say, documentation might not seem too helpful to you per se, because you've done it, so you know. But you have to see it as a requirement for the next person who takes over the project, right? Or for when you're not there anymore, right? And I'm sure, like, there'll be times when you come in, you pick up a new project that someone worked on, and you'll be like, I wish they had done a better job documenting, right? And you don't want somebody else to say that about you as well. So just to wrap it up, like, again, this is just something I share with new folks on the team. It's not meant to be, it's not scientific. A lot of it is just based on my own personal experiences and what I've gone through. But I find it to be helpful. It's overwhelming. There's no doubt about it. It's very overwhelming. And so what we typically do is we set objectives for individuals as they ease into the job. It's like, okay, first couple of months, you get a chance to focus a lot more on the data piece. Then we make sure they have good experience when it comes to coding, using the stack, the communication aspects of it, and just project management. Like, you ease people into these things, right? But over time, you have to build these best practices and make them as part of your BAU, business as usual. If you really want to succeed at your job, if you want to really stand out, and if you want to have an impact more than anything else, right? It's all of us are in this field because we want to see the impact of the work that we do. And so, again, as I said early at the beginning of the talk, one of the main ways where you make sure that your solution is useful, it's impactful, is to adhere to certain, this particular framework, at least where I work and what I've been exposed to. The rest of these slides are just parting sort of messages. Just be realistic. When you go out there's a lot of time spent on data prep, as I told you before. Majority of your time goes towards that. Of course, the rest is development and testing. I talked about designing and solutions or requirements gathering as well. That takes a lot of airtime at the beginning. But some key message things to remember is diversity is important, right? When you have a data science team, you want people who are from a variety of backgrounds, not diversity just in. So what are some of the things I aim for my team? Male, female diversity, LGBT, Black talent, visible minority, and so these are like your traditional sort of diversity pillars. But in addition to that, it's the diversity in thought, it's the diversity in experiences and in personalities. That's extremely important to bring to a data science team because you're working with data. Data are representative of people. You need people who come from, are a fair, you need people working on the data who are a representative sample of the population because there's so much nuance in the data and there's so much damage you can do and so many great things that you could do that you would not otherwise know to do without having a diverse team. Second, focusing on experience, right? Uh, the, the the more you focus on customer experience, the more innovative you can get because you're essentially solving and removing roadblocks from the customer's way, so they can engage with your team, with your product more, with your organization more, and that provides you with a chance to innovate, right? At every step of the way, understand your client, so whoever your business stakeholder is, understand your data, understand, as I said, the product, the business itself, um, focus on their experiences as well and what they need to be supportive and to back you up when you've built a solution. To say, yeah, I like this solution, I like this thinking, I like how this is going to help me. I'm going to take this and use it, right? Without that focus, though, on their experiences, on their needs, and how you can help them, you might not necessarily get them. So I'll just wrap it up there. I hope that was helpful. I know it was very wide, it was very broad. I talked a lot about what analytics is, why it's important, what are some broad methodology, like perspective, from a perspective of like high level, what are some of the pillars of things you need to do, and some of the pitfalls or best practices, like step by step when you start a new job, when you start as a data scientist, what are some of the things you need to do, right? Or just an analytics professional in general. And I hope that was helpful. But now we have 10 minutes, I believe, Konika, if I'm not mistaken, for questions. If you want to do that, or
Yeah,
you let me
sure.
know if there's any other way we want to use this time.
So first of all, really thank you so much for giving us a broad idea on data analytics and data science. It was really helpful according to me. You not only shared the things about the field, but you also gave us the professional tips. So I feel like it's really good. And just two quick questions that just popped up in the chat. The first is: are there any particular fields in the commercial area that is hard to apply a typical analysis procedure?
Um,
That
okay,
was like
that's it.
really early in your slide deck, so it's
Okay,
coming now.
let me see if I can understand the question. I don't know if they can speak to it too or not. Is that
Okay.
possible?
I don't really think so, but it was, I
Okay,
think,
that's
in
fine.
the slide second or slide third of your deck.
All right. Yeah, that's fair. That's fine. Um, so I guess particular fields in the commercial that is hard to apply to typical analysis procedure. Um, I think maybe it was it. I have a feeling maybe the question meant to ask whether it's particular analysis that you can do within a business, maybe. But um, I guess the typical answer you would give or you get for these sorts of questions is like fraud or risk, right? We build a lot of fraud models for fraud to catch fraudulent activities or to catch scam, whether it's internal within the organization or it's happening to our customers. Doesn't matter. It's all considered fraud or scam, right? And in that area, you can't just build anything. As I said before, it has to be explainable, has to be usable, has to make sense to the end user, which is your fraud partners or your compliance and regulatory folks and so on. And so not every type of model is helpful here. You need a model that helps you rank your features. You need a model that's transparent and it's explainable and you can back it up. So yes, there are areas where there's certain things that you can't do. And that's where you have to get really crafty and creative, right? Because there is a better solution out there, but you just can't use it. As an example, I don't know if that answers the question, but I hope it does. I think that's what the question was about. That would be my read of it.
Yeah, I personally feel so. There's one more question from the same person. That is like, what kind of projects look interesting on undergrads who want to intern as a data scientist?
What kind of price are you looking on who want to intern as a day? Oh, I see. So okay, so that answers it, Carl. Okay, great. The types of projects really, um, I like to say it doesn't really matter, but at the same time, if you have a niche, like a special area that you're interested in, then you probably want to focus on that a little bit and show that you have experience. So, you know, if you're interested in customer analytics in general or product analytics, lots of Kaggle data sets you can use in that space. If there's it's environmental stuff, for example, social impact sort of projects or products. Again, there's so if you have an interest, definitely go ahead and find the right data set that speaks to you and you are passionate about. That never hurts, right? But in terms of the actual machine learning types of machine learning, so I think you want to have at least one or two supervised and one unsupervised, a couple of unsupervised exercises as well. Typically, what I look for when I look at a resume is um, for someone especially freshly coming out of school, right? Because there's not a lot of expectation on the experience side, but on the expertise side, you want people to say to showcase that, hey, I'm so passionate about this field. I've done these hackathons and or I've just done these personal projects. And here's the GitHub link. So I can go and quickly look at how they code, what the solution is, and so on. And at that point, it's like you want to make sure you have machine learning projects that you've done. If you can do XGBoost models, that's great because it's such a widely used algorithm, probably like GPM now, out there. Forecasting exercises are always helpful. It's such a wide and complicated field that there are not many people who are very good at it. Understanding A/B testing, and maybe if you can do something like that with synthetic data, um, it's a very, very in demand and hot expertise to have, and not a lot of people do. So that's another one that could be supplementary or complementary to your modeling skill sets, right? And when you turn it up a notch, lots of different cool machine learning stuff that deep learning stuff that you can do, mostly on the NLP side, because that's where the majority of use cases are these days. But of course, there are areas where they are interested in image or computer vision as well. And if you can do that, if that's what you're interested in, passionate about, make sure you do that. Write Medium articles, post it on LinkedIn, put it on your resume, push it onto GitHub, maybe create even a small deck or like a PDF that sort of highlights what you've done, and make sure it's uploaded to your repo as well. I think that would be super helpful too. Those are the things that kind of differentiates people who are truly passionate. They're very curious, which is probably the most important attribute in this field. You need to be curious, and those are some of the ways you can showcase that you have those attributes.
Thank you so much. I feel like all the tips would really help hackers to like keep in mind when they apply for co-op or intern positions. But just I was very curious. Like most of our hackers are second year and third year engineering or comp science students. So what do you think should be the technical skills like they should be focusing on if they want to pursue this thing like this field in their future? So, do you suggest any specific programming language or any specific platform or any specific like the database system that they should be focusing on so they can like excel a lot?
Yeah. It's kind of a cliche at this point if I say SQL and Python are the kings in our field. Um, Different organizations have obviously different requirements. There are places where you need to be good at Java, for example, or just generally be at least well versed in object oriented programming. But a lot of places are focused on scripting, so like Python would do the job. I don't expect people to have PySpark experience or any Hadoop experience because it's not something that's readily available. So if you can find an internship or if you can find an experience where you can manipulate large tables and work with big data, that always helps. But if you can't, don't stress. It's understandable. You're coming out of school. Aside from SQL and Python, when it comes to visualization, naturally it's either Tableau or some of the other comparables to Tableau. Again, that's something that's expensive. You can't always get a license for. If the university supports it in any way, definitely go for it and find a way to get some experiences on. If not, just use any other dashboarding tool just to showcase that you can do visualization. You are able to tell a story from your model or explain your model essentially. I guess to be more specific, a lot of comp sci and engineering folks who come out and I don't mean this in. I know it's not going to come out right, so I apologize in advance. But it seems like a few steps are jumped, right? So what I mean by that is sometimes we ask the most basic questions on a logistic regression or just a simpler multivariable regression, and we don't get the answers that we want to hear, which kind of tells you that there's not enough depth, and there's not enough sort of the foundational stuff is not there, right? Make sure you cover those two, because anything that you do in terms of like even deep learning, right? There will always be times where you need to go back to the basics, always, and you have to know those basics, and that's what we test for, or a lot of places actually test for, right? And so while it's really cool to be able to do object detection in a video, or to grab a code from somewhere and do text generation or text classification, these are really amazing cool things to do. Don't lose sight of the fact that you need to understand how those things work and how to go back to the basics. That's also super important as well. Um, I don't know if there's anything else aside from tools and the type of models and whatnot that I can share. Konica, I don't know if there's anything else you wanted me to talk to.
No, I think that's really great. Thank you so much for your time and all the experiences and the details that you shared with us. It was really lovely, having this presentation done on the platform, and great talking to you again. For all our hackers or people who are joining this live streaming, we have another workshop in 30 minutes. That's on Make Your Own Discord bot. It's from the CS Hub at York University. So, hope to see you all there and have a great night. Thank you so much, Professor, once again.
Thank you so much, and I look forward to connecting with anyone who is interested to discuss any of these items more, or just be in touch. So look me up on LinkedIn, and I would love to stay connected and get to know some of you as well. But I really appreciate the opportunity and the chance to be able to give back and share some of my experiences. Thank you so much.
Yeah, pleasure is all ours. Thank you.
All right, take care. Bye.
Bye.